Measurement and instrumentation for second year training. So in unit 1, we have the static and dynamic characteristics of measuring instruments. So static characteristics are the one which does not vary with time, it remains constant, whereas dynamic characteristics are the one which continuously keeps varying with time. First characteristic under the static characteristics are accuracy. So in case of any measuring instrument, the most important quality of an instrument should be how accurately it measures the actual value. So the actual value and the measured value should be in very close proximity. The difference between these two should be at a very minimum value so that the instrument can be used very effectively and the values taken by the instrument is also the most accurate one. Whereas in case of precision is about, for example, if the same instrument has been used for many number of experiments or for more number of so still the instrument should have the ability to show the most accurate values. So that is what precision is all about. Whenever number of times the instrument has been used, or for whenever experiments it has been used, it has to show the accurate values. Sensitivity is how quickly the instrument is capable of sensing the changes in the input parameters and immediately showing the changes through the deflection unit and graduated scale in case of an analog instrument. So sensitivity is how in case we are taking the load test of any of the motors in the machines lab, as soon as the load has been changed, immediately the instruments need to show the changes in the current and voltage instantaneously. So it has to be sensitive enough that it captures the changes in the load and immediately the changes are being reflected in the current and the voltage values. It is the ability of the instrument to show the values even if it is being used for a prolonged period of time. Resolution is also very similar to sensitivity, being very sensitive to the immediate changes in the input parameter and showing the corresponding reflection. Threshold is in case of certain instruments, there is a minimum input value which is required by the instrument to start showing any kind of reflection. Certain instruments they are also very accurate, but still immediately the changes in the input parameters are not reflected by the reflection of the pointer. So it takes a minimum time after which the pointer will start to reflect and show the measured value. So that is called the minimum parameter value is called as the threshold value. And repeatability is the same instrument has been used for any number of experiments or for a 10 to 20 number of readings also. It still should have the ability to show the accurate values. And these two graphs depict, for example, this is the normal characteristics that has to be obtained by the measured values. But we have a slight shift, and this is the graph that has been actually obtained from the measured instrument. So this difference is called as the span difference. So after taking the readings, when we plot the parameters on a graph, so there is a difference between the normal characteristics and the characteristics obtained by the values from the measuring instrument. So even in case of the second graph, it is where the graph should begin from the origin. But from the values that is taken from the measuring instrument, this is the graph that has been obtained. Where we can clearly see that the origin has been shifted from 0, 0 to 0, some other value. So this is called as zero drift. As in case of stability, it is stability of the instrument to regain its initial conditions even in case of any disturbances. For example, any switching disturbances or if there is a sudden increase in load or there is a sudden cutoff of load, whatever it is, the instrument needs to be very stable. Instrument we take is going to be certain minimum tolerance value where the plus or minus values should be accepted. So that is what tolerance is all about. So the value measured by the instrument should fall within the tolerance range. Only then those parameters will be accepted or those parameters will not be validated. Range of span is, for example, whatever is the required value or range of the instrument. For example, in case of ammeters, if we require 0 to 10 amperes, probably if 0 to 10 amperes ammeter is not available, we can move to the next higher level, but not to a range that is lower than what is required. So we always prefer the exact value or the next higher value, but definitely not the lesser value. So in case of linearity, it is the relationship between the input and and the output parameters. So in case of linearity, this is the actual result that has to be obtained. The square is the result that should be obtained from the measured values. But in case of linearity, this is the kind of graph. The straight line is the graph which we obtain from the measured values. So the difference between these two is going to produce the errors. So that is the kind of response that we have received from the measured parameters. In case of hysteresis means, for example, certain parameters will be changed from a negative value to a positive value. So in that case, the instrument also shows the negative value and then also the positive value. But still, the instrument does not have the ability to come back to zero, whereas it keeps on toggling between the two ranges, the negative value and the positive value. So this is called as the hysteresis loop. Next, moving on to the dynamic characteristics. In case of dynamic characteristics, we do have the speed of response. For example, in case of measuring the speed of motor, the speed is going to keep on continuously changing. When we increase the load, there is going to be a drop in the speed. So in those cases, those instruments need to have the ability to immediately respond to the changes. So that is the how quickly the instrument has the ability to respond to the changes is called as the speed of response. Whereas in case of measuring lag is the response of the instrument in reference to the input parameter. So if the input parameter is changed, there is going to be a small time delay after which your instrument will start to respond to those changes. So that is what is called as retardation type and time delay lag. Fidelity is nothing but the degree to which the instrument indicates the changes of the measured quantity. In case if the input parameter has been changed, immediately the instrument should have the ability to show the current value or the new value. Also, the value shown now has to be very accurate one. So, dynamic error is the difference between the actual value and the measured value. So, these are the static and dynamic characteristics. Thank you.